All right, so the topic that I'm going to be presenting on today is object-oriented concepts from the Java Learning Trail. So let's get started. So here we have a nice little cartoon that kind of shows the world that would be seen by an object-oriented programmer. Some of my favorite things here is the indoor session initializer and your visitor monitor interface. So it's just kind of some fun things to kind of get you thinking a little bit about objects and how they are in the real world and how they relate to programming, as they're very similar. So, what is object oriented programming? So, object oriented programming is a solution to a problem that the coders of old encountered. Um, you can think of it in real world examples. If you have a car and you buy a brand new car and then the door handle breaks on your car, you're not going to want to replace the whole thing. Or if a bolt breaks, you don't want to replace the whole thing. And you want the same thing with your code. You want your code to be readable, you want it to be maintainable, and you want it to be able to be worked on as a team. And so when it's thought as objects, it's much more efficient and it's able to do that. A good example is a lamp in the real world. If you think about it, it has two states. It has an on and an off. And it also has two behaviors, which is to turn it on and to turn it off. And so as you can see, the object-oriented programming is similar to this lamp. Is a very basic example that there's states and related behavior in object-oriented programming. So what are the benefits of object-oriented programming versus just writing all your code out in procedural based? It was interesting because when I first started to learn to code, I would do stuff in a very procedural way, and I would write apps like that, and the apps would get really big, the code base would get really hard to maintain, and it just wasn't the best of all ways to write it. And so one of the benefits of object-oriented programming is the modularity. It can be written and maintained independently from the rest of the code. So you can start thinking of that as the object, the car example we used before, a bolt, or a piece of the engine. They're information hiding, so using an objects method, the internal details will remain hidden from the rest of the program. And code reuse. One really good thing is to allow code to be shared between other developers and to test your code easier. So that leads us into debugging as well for pluggability and debugging. If you have an issue, it's a lot easier to track it down if you're using object-oriented programming because you can narrow it down to the exact object or class that's misbehaving, rather than trying to go through and step through the entire program and not having any idea where it is. So you can think about car repairs. Cars, all their pieces are interchangeable. You can pull pieces out, you can put new pieces in, and it's the same way that code should be thought of, as you can pull pieces out and put pieces in to fix things or to add functionality. So classes are the first part that we're going to get into, which are the blueprint from which individual objects get created in object-oriented programming. When you have a class, it is used usually within another class in your application, and like I said, they're the blueprints, so they provide some basic functionality. So when I was growing up, I played a lot of a game called Battlefield Bad Company 2, and in this game there were a couple of weapons, and for me it helps to think of object-oriented programming in terms of real-world examples, so I can deconstruct kind of how things are actually done rather than just reading about it. And so in this example that I'm going to show about a class, I use the example of a rocket launcher. So you'll notice that we have the class rocket launcher, which initializes some basic variables. The first one is just the altitude of the rocket, and then it has a method in there for gravity drop on that specific rocket. And in that game, there was 3 rockets. There was an RPG, a Gustav, and an AT-4. And these 3 rockets did different things, but they all shared things that were in common. They were all a rocket launcher. They all shot a missile. That missile had gravity drop. They were all from the same mold kind of thing. They were all similar in that aspect. And so as you can see here, we have our RPG. It's the type is a rocket launcher, and we initialize a new object, so an instance of that object. So the RPG, the Gustav, and the AT-4 are all rocket launchers, to say. And then we invoke our method on those, and we can change the values that are put in there. So the RPG was a really crappy weapon, and the gravity drop was really bad. And then you had the Gustav, which was a little bit better, but still pretty bad. And then you had the AT-4, which barely had any gravity drop at all. And so you can see we're applying those methods there. So classes work great, but then you start thinking of what if you need to vary one of your objects a little bit. So here's a nice little joke for you. What's the object-oriented way to become wealthy? Inheritance. All right. So inheritance is a way for subclasses to inherit properties and methods from a superclass. So what is a subclass and a superclass? So in the last example, we had a rocket launcher. We had the superclass, which would be a rocket launcher, and then we're going to create another class, which is called the AT4, which is the subclass, which the difference functionality in there is going to be that it has a guidance system. So it's going to have all the same properties as a rocket launcher, but we're going to expand or extend the superclass with a subclass. And so the way to do that, you'll notice in this example here, is that we still have our original class, which is the rocket launcher. And then below that, we have another class, which is the guided rocket class. And that class extends the rocket launcher. So it is a subclass of the superclass rocket launcher. So we have some more initialization. There's some different variables. We're going to add a little method to guide your rocket here. So you have the direction, you have the player direction, which those are our variables, and then you have a little method to guide the rocket in whatever direction you want. So you have your methods that you're invoking, and as you notice, it's similar to the first demo, except for down at the bottom we have the AT4.guide rocket. So we are applying our new method that's found in that subclass along with the original method, and you'll see that we didn't have to change anything for that subclass to have those the superclass's properties. We just added the extends thing. We didn't have to define those twice, is what I'm trying to say. So the subclass allows us to save time by kind of expanding upon that superclass, and then now we have a class for guiding rockets. So the next part is an interface, and you may ask, like, what is an interface? So a good way to think of an interface is that it's a type of contract between your class and the methods that it's going to be using. So you can kind of think of it as a TV and a remote. You're not going to want to have a remote controller that has a power button if your TV can't turn on and off. You're not going to want to have a volume button if your TV doesn't handle volume. So that's a way to think about it. Your interface is going to define those methods for your class, and the thing to note is they have to be used in that class if you define them before your application will compile. So here is an example of that. So we're going to use an interface this time to make a rocket launcher. So here we have an interface of rocket launcher, and we have the two methods that we're going to be using in there: apply gravity drop and decrease ammo. And then if you go into the class, we now have those two methods that are being used. So our program's not going to complain there. But if I were to take out the decrease ammo or to take out the apply gravity drop, because our interface specifically says that we're going to be using those in our class of rocket launcher, it's going to complain and yell at me for not using those. All right, and then the last piece is a package. So a package is a namespace that organizes a set of classes and interfaces. You can kind of think of them as folders on your computer, and they allow code and other functionality to be included in a program. So they allow the programmer to focus more on the design of the application rather than the infrastructure. Because it would be really time consuming if you had to rewrite every single thing every time you tried to write a program. So packages help out with that functionality. So in a nutshell, that is object-oriented programming.